Hello everyone, good morning. So today we will understand the last but the most interesting topic of this particular chapter, that is special types of quadrilateral. As you have already understand about parallelism, Pythagoras theorem, where it is used, how it is used, as well as the different types of quadrilaterals along with their different properties. Now let me just focus on the last but the interesting topic of this particular chapter, that is special types of quadrilateral, and the concept is congruency. Yes, my dear students, congruency. Congruency is applicable to different types of figures which is visible in our day-to-day life, but we are primarily focused on triangles. Yes, we will primarily focus on triangle, and by the use of triangle we can actually solve different questions which are there in quadrilaterals. So without wasting any further time, let's start. So let's just understand about congruency. Congruency by its nature, it means same. It's not similar, it's same. Like if I'm making let's say these two pens are same because they have same cap, same figure, as well as you can say same model, right? So we can say that these two pens are same, or these two pens are congruent. For example, one more example could be your different books. Like for example, the students which you have, the students of class 8, they have the mathematics book. They have their mathematics book, right? And the mathematics book will be same as compared to one student with the other student. The book is exactly same by their dimensions means by their length and breadth, if we want to measure, by their angles, everything, sides, everything, right? So we can say that these two books are congruent to each other. Congruency means same, right? So in case of triangle, what exactly that I want to tell? In triangle, if you see, in triangle, these two triangle, let's say, are they same? Are they same? I don't think so, because if you see, if you just compare the sides with each other, then you can able to see that this side is smaller than this side, as well as this side is smaller than this side, and this side is smaller than this side. We want to compare with the corresponding sides. We have to compare the sides with their corresponding side. That what I want to tell you, that AB, if you see AB, its shape is in this shape, right? Inclined shape, right? And that inclined shape will be exactly look like this EF. So that means AB and EF are the corresponding sides, right? Corresponding sides which look same, which look similar to each other. That will be the better word, right? So if you see AB and EF, if we just compare AB and EF, we can able to see that EF is greater than AB. EF is greater than AB, right? Next one, AC and EG, because AC and EG, these two are also corresponding sides. So EG is also greater than AC, and like that way EF is also greater than, sorry, not EF, FG is also greater than BC. So in that case we cannot say that these two are same. We can say that these two are similar, or that will be the different topic, similarity topic. I don't want to cover that one, right? So primarily we will focus on congruency. So in that case we cannot say that these two figures are congruent. One more thing, when we are comparing, right now we know that by comparing the sides we can able to find out that yes, these two figures are not congruent. But if let's say right, and then these two figures, and at this angle all the angles are 60 degree. This is also 60 degree. So if we just compare these two figures on the basis of angles, then we can say that these two are same, because in angles also we have to compare the corresponding angles. Corresponding angles means that which looks similar to each other, right? So here 60 degree and 60 degree both are same, 60 degree and 60 degree both are same, 60 degree and 60 degree both are same. If you are just confused about the whole three are 60 degree, that's why let me just draw one more figure for you. Let's say in this case this is 60 degree, let's say this is 40 degree, and let's say this will be how much? This will be, let's say, 80 degree, right? And in this case also this is also 60 degree, this is also 40 degree, and this is also 80 degree. So in that case, if you just compare the corresponding angles, these two figures are, on the basis of angles, these two figures are congruent. But congruency does not mean that you have to only compare the angles. We have to compare the sides also. So in that case, can you able to say that right now I have just drawn these two figures randomly, right? But if you just measure it by using the ruler, then you can able to say that whether it is same or not, right? But let's say by hypothetically, let me just draw one more figure for you. Let's say this two figure. These two angles are also equal, 60 degree, 60 and 60. And how I have shown you that for sides, if two sides are equal, then what mark that I have to give, that cut, this one. These two sides are equal, these two sides are equal, and this one is also equal. Then at this point we can say that these two figures are what? Congruent. These two figures are what? Congruent. And what is the symbol? We cannot write congruent in all the questions, right? Let's say this figure is ABC and this is EFG, right? So we cannot say that ABC triangle, that is the shape of triangle. Triangle ABC is congruent to triangle EFG, right? In letters or in sentence we cannot write like that. There is one special symbol which represents congruency. So what is the special symbol associated for congruency? That is this one, equal sign and one curly sign, right? Equal sign, one curly sign. So by this, using this sentence, can we just replace this sentence by using the symbol? Yes, we can. Like triangle ABC is congruent to triangle EFG. So that is the symbol for congruency. When we put this symbol in between two triangles, then we can say that these two triangles are absolutely same. So that is the basic concept of congruency, right? Now if you see these two diagrams, the whole data are almost given. Almost, no, every data is given. Let's say all the three angles are given, all the three sides measurements are given. But in questions, on doing some questions, we cannot get the this amount of data, right? For example, the three sides measurements are given and the three angles are also given. It will not be the same case. But at that time, by looking on this particular problem, there are 4 to 5 congruency methods. There are 4 to 5 congruency methods. By doing or by following that congruency methods, we can able to say that these two triangles are equal. What I have just said that there are 4 to 5 criteria of congruency. right, where shorter amount of data will be given, and by looking on that data we can able to say that these two triangles are congruent, right? So we have to follow that routine, properties. We have to follow that property, and on the basis of that we can say that these two triangles are congruent. All right, so now let me just disclose one by one what are the different properties, or you can say it's not property, what are the different methods by we can say that the triangles are congruent. So let's just understand on that part. So let's just understand one by one what are the different methods, right? The first method is SSS Congruency. SSS Congruency. So what do you mean by SSS Congruency? That means side, side and side congruency. What does it mean? If you just see, I'm making the diagram also for your benefit. Let's say these two triangles, in these two triangles, if all the sides, or you can say all the corresponding sides are equal, let's say this one is A, B, C and this one is E, F, G, right? So if you see that these two sides are equal, corresponding sides, as well as these two sides are equal, and last but not the least this side is also equal, then we can say that by looking or by using SSS congruency, we can say that what will be the conclusion, that triangle ABC is congruent to triangle EFG by SSS congruency. That's it. How we can say that? By using this particular method, that is SSS congruency. What does SSS congruency means? SSS congruency means that the corresponding sides of the triangles, if they are equal, then we can say that these two triangles are congruent or same. Now the second one is SAS congruency. SAS congruency. So SAS congruency, now you can able to understand or you can guess, that is side angle side congruency, right? So in side angle side congruency, what does it look like? These two triangle, right? Now the naming will be same. The naming will be same. Let's say A, B, C and E, F, G. Side, angle, side. So that means between two sides there must be one angle. Between two sides, if you see over here, these two sides and between one angle. So we have to pick up that type of sides which includes one angle in between it. Or you can say that these two sides, let's say this side is equal to this one, that is AB equal to EF, as well as AC equal to EG. Then in between these two sides, which angle it will lie? Which angle will lie in between AB and AC? Angle A. And in between EF and EG? Angle E. So if this type of things are happening, then we can say that triangle ABC is congruent to triangle EFG. Triangle ABC is congruent to triangle EFG by which criteria? By SAS congruency. That's it. SAS congruency. So what does SAS congruency mean? Two sides in between one angle. Two sides in between one angle. Let's say if you take these two sides, AB and BC. So what will be the angle in between AB and BC? That is angle B. And in case of EF and FG, angle F. Make sure that not just our concern is to create one angle in between the sides, as well as it is our motive to create the corresponding sides. What does it mean? Then this side should be equal to this side. If the condition will look like, let's say this triangle and another one is this triangle, right? So if our motive is to just create SAS or angle in between two sides, then we can create like this to this one, right? SAS, and let's say this one and this one. But these two triangles are not congruent. Why? Because the corresponding side of this side is this side. No problem, no problem. But if you see the next side, this side is the base side, right? The base side. So in the base side, we cannot say that this side is equal to the third side. We have to create the base side that should be equal to another base side, and as well as the angle which lie in between these two sides should be equal to this angle. We have to create like that. Is it clear? So that means we have to create something as it is which looks same in two triangles. If you see these two triangles, the same things are happening, right? But if you compare these two triangles, the same things are not happening. We are just creating SAS, right? But it doesn't mean that by creating SAS it will follow, right? The pattern should be same. Make sure you have to remember this point. The third one is angle side angle congruency. So what does angle side angle? Angle side angle. Now you can able to guess what does angle side angle mean. It will be absolutely vice versa method of side angle side. In side angle side, there must be two sides lie, and there will be one angle lie between the two sides. In case of angle side angle, two angle would be there, and there must be one side which will be between the two angles. Let's say this angle is equal to this angle, this angle is equal to this angle. So the associated, or you can say in between line will be what? In between side is this one, this two angle, and in between side is this one, right? Not this one, because this angle and this angle, if you want to create this side in between, then it must be equal to this angle, should be equal to this angle. Then we can say that these two sides are in between the two angles. But in case of this particular diagram, A, B, C and E, F, G, this side must be equal to this side. So that is the criteria for angle side angle. And the same thing, we have to write the same thing, that is triangle ABC congruent to triangle EFG by angle side angle congruency. Same thing. Make sure you just write all such things in your notebook, because it is very much important for you to note it down. Last but not the least, that is RHS congruency. RHS congruency. So what does RHS congruency mean? Right angle hypotenuse side. So that's why I have discussed Pythagoras theorem before congruency, because at the last stage you need hypotenuse concept, and that I hope that is clear to you right now. So right angle hypotenuse side. So what does that mean? Right angle. So that means there must be one right angle. Let's say this to figure. This to figure. Okay, done. So now in this to figure, two triangles are there, A, B, C and E, F, G. So there must be one right angle. So we can easily observe that these two angles are right angle, right? These two angles are right angle. So what is the opposite side of right angle? What is the opposite side of right angle? That is, we know that that is hypotenuse. So that means right angle hypotenuse. So that means after comparing the right angles, which should be equal to with each other, we have to compare the hypotenuse, whether the hypotenuse are equal or not. If it is equal, then we can just put that mark, right? Hypotenuse, right angle hypotenuse and side. So how many sides are remaining? Two sides, these two sides. So whether it is equal to the perpendicular, corresponding perpendicular, or whether it is equal to the base, that does not make any difference. But if you just comparing the base with the perpendicular, then that should be wrong. So base, it must be equal to the base. So that's it. That's about RHS. And finally we will write down that triangle ABC is congruent to triangle EFG by RHS congruence. So that's all, right? By using these 4 methods, we can able to solve different questions of quadrilaterals. So what does that different question means? If you see in your example before exercise 5a, there are some theorems or there are some proofs, right? So to solve that particular proofs, we need congruency methods. And there must be, now the question is that, sir, you have told us that the whole sides must be equal to the whole sides, and the whole angles, it should be equal to the whole angles. Whole angles means if in a triangle there are 3 angles, it must be equal to the corresponding 3 angles of the other triangle. But in that particular case, these things are not happening. So how we can say that these triangles are congruent? By just looking on that method? No, there are some more method. There is one more method which is associated with this congruency. So what is that? If you see in side or side angle side or ASA or RHS, in all the 4 methods, there is one thing. After congruency of SSS, now in the case of SSS, we have not compared the angles with each other, right? But when we put that sign over here, then automatically this angle and this angle is equal, this angle and this angle is equal, and this angle and this angle is equal automatically. Why? Because the triangles are congruent. We don't need to compare that part also. When we put congruency sign in between 2 triangles, then automatically the other condition will be applicable. And there is one method to prove this one, that is called as, let's say in this case what happened actually, after proving congruency, we have just informed that these angles are also equal. So that means after congruency, what does it happen? Like after congruency, angle A is equal to angle E, angle B is equal to angle F, and angle C is equal to angle G. That things are happening, and there is one criteria using for this type of equal to, or you can say after congruency, the whole things are getting equal with each other under this part, that is called as CPCT. So what does CPCT means? CPCT means it means corresponding parts of congruent triangle. So what does CPCT mean? Corresponding parts of congruent triangle. So that means after congruency, the corresponding parts are automatically equal with each other. So in that case, after congruency, by using SSS congruency method, after congruency, what does it happen? That all the angles are automatically equal with each other. By which criteria? By CPCT, that is called as corresponding parts of congruent triangle. In case of side angle side, automatically this side is equal to this side and this side is equal to this side. And sorry, these angles are equal with this angle, and the last but not the least, this side is equal to this side. Using what method? That is called as CPCT. In this case, these two are equal, this one is equal, and as well as this angle is also equal. Why I'm making different types of cuts over here? To make you understand that this angle is equal to only this angle. So that means the corresponding angle must be equal. If you see, there are only two marks, right? 2 marks. That means 2 cuts. That means these 2 angles are only equal with each other. We have to compare the corresponding side. Make sure your attention must be there on the corresponding sides, right? All the sides are not equal to all the sides. The corresponding sides are equal to the corresponding sides. That needs to be clear. In that way, this angle and remaining this side, or the whole angles are also equal with each other, right? So that's it for congruency. I hope that congruency method is much more clear to you. Now that's all for this session. I hope that after watching these 3 videos, now the whole concept are getting clear to you. After this session, we will now solve hell number of questions. We will solve multiple questions of this particular chapter to make you understand what will be the application of these methods. Congruency, whether it is congruency, whether it is Pythagoras theorem, or whether it is parallelism, or what are the types of collateral, everything, right? We will see that what are its application. So that's all for this video. I hope you have enjoyed a lot, and if you found something doubt related to this particular topic, make sure you do contact me. That's all for today's video. Thank you and have a nice day.